So when Greengrass was first announced as a service, I reached out to the service team and to the people who were involved in building it and said, why is it called Greengrass? And the only answer I got back was lemongrass was already taken, which didn't make much sense. And I thought about Greengrass, and I thought about it this morning actually when I was walking from my hotel here and I saw all the frozen grass that I was walking past, not as lush as this. I thought grass can mean many things. It can be a platform for a sporting ground, it can be a garden, it could be a place you take your family for a picnic. In many ways, Greengrass can be many things, and the Greengrass platform can be many things. For us, it represents a big bet on Amazon and how we see the future of IoT and edge computing, and I think it's pretty exciting. So, what is Internet of Things? Who understands what Internet of Things is? So, Internet of Things, the world of connected devices, so smartwatches, autonomous cars, smart cities, etc. Many of these connected devices. The story that I like to think of is that when I was growing up in the 80s, everything started to show up with a digital clock. I don't know if you remember this. You know, microwave oven came with a digital clock, your car came with a digital clock, everything came with a digital clock. And in a similar way, today, everything's showing up with a processor, everything's showing up with an operating system, everything's showing up with a Wi-Fi connection, and these devices are getting cheaper and more powerful. And where are we going with this? So, in the next few years, we're going to see more connected devices than mobile phones in the network, on the internet. We're going to see devices that are moving from analog to digital. So devices that used to be analog, like thermostats, etc., are now digital. And that allows you to automate and personalize and integrate a lot of these systems. But a lot of them are going to be isolated in particular verticals. So you'll have a solution for this particular vertical and a solution for this vertical. And we need to move to a platform approach where the data is available across all these verticals, so we can look for insights and be proactive about how we improve and take action on the systems that we work with. So we need to move to the integration of things. And we spoke to our customers, and they told us that most data actually doesn't reach the cloud. So if you think about industrial machinery, you think about manufacturing plants and PLCs, a lot of that data gets processed and needs to be responded to quickly at the edge. If you think about medical equipment, a lot of times medical computational transactions are very short and may contain personally identifiable information, and they need to be processed at the edge. And if you think about situations like the Mars rover situation, a lot of those environments are in hostile, low network connectivity environments, and the data processing and compute needs to happen at the edge. So have a think about the edge in your world, the edge in your organisations, in your homes, in the world that you live in, and what the edge means to you. And when we talk about the edge, we say at Amazon, we realise that it came with these 3 laws, and these 3 laws are long-standing laws which we're going to be with for the foreseeable future. So firstly, the law of physics. And that talks to latency and also network and isolation. So for latency, if you have a crash avoidance system, for example, you don't want that crash avoidance system to have a round trip to a cloud data center to make a decision to avoid a crash. You want it to be processed at the edge. And if you think about a remote mining site that might have low connectivity, might be poor mobile coverage, for example, it might be even some processing that's happening on a Dreamliner in flight. These environments are very isolated physically, and that talks to the law of physics. The law of economics talks to the fact that the cost of networking is dropping, but it's not dropping as quick as the cost of compute and storage. And a side effect of that is we're producing a lot more data than we used to, and it's getting more and more difficult to move around and more costly. So we need to think about how we move data around, be smarter with it, because it is quite expensive. And then the third law is the law of the land. And for legal and compliance reasons and concerns about privacy, a lot of customers want to keep their data close to them, and sometimes there are data sovereignty considerations as well. So we thought about these 3 laws. We thought we're stuck with these 3 laws. How can we bring the benefits of cloud computing and cloud development and cloud analytics to this edge environment? So with cloud development, you have everything as an API, infrastructure as software, You have quick iteration and development cycles, very adaptable for the business or the organisation that you work in. And with cloud analytics, you can spin up a data warehouse in very short time, or a Hadoop cluster, and we want you to be able to take advantage of those services even within the constraints of these three laws. And when we think about Internet of Things at Amazon, we visualise them in these three pillars. We have the Things pillar, and that's where your devices live and sense and act, and I've referred to that as the edge today. You have the Cloud pillar in the middle, and that's serves most of your compute and storage needs. And then on the right, you have the Intelligence pillar, and that's where you look into the data that you've collected and look for actionable insights and the ways of improving how you operate. And we introduced a couple of years ago now the AWS IoT service. And this allowed you to configure devices to connect securely to the cloud. They would connect in and be able to pass messages between devices and Amazon services. It also allowed you to do this securely with best-of-breed security as far as connections, etc. So if you look at this diagram, you've got trucks and thermometers on the left. They're connecting in. They're using MQTT, which is the protocol of the Internet of Things. It connects into the IoT device gateway using X509 certificates or using IAM credentials. You then post messages to an IoT topic, and other devices and Amazon services can subscribe to those topics to get those messages. You can then write rules using the IoT rules engine to route parts of those messages or some of those messages directly into AWS services for data collection or data analytics. If you want to use Elasticsearch, you can create dashboards really quickly. And we introduced this this idea of a thing shadow, and that's shown in the diagram as the grey truck in my example. So the thing shadow service is unique to AWS, and it solves a problem for developers. So developers always, when they're writing code, want to be able to query the state of a thing and also set the state of a thing. Except in the real world, things get disconnected from the network, they break down, they lose power, etc. So how could we provide a service where developers could always query the last known good state of a thing and then also set the state? So for in my example here, imagine you have a thing in the edge, it connects into the AWS IoT service, and it reports its state as version 1. You as a developer want to update that to version 2. You can update the thing shadow to a desired state of version 2. The device, when it next connects in, sees that it's meant to be at version 2. It can go about upgrading itself, and after it's upgraded itself, it can report back that it is now version 2. The developer hasn't had to do any of that logic. They've just had to query the thing shadow service. And I've gone into that a little bit more detail because it talks to how Greengrass works later. So we introduced the Greengrass service, and what is the Greengrass service? It brings the benefits of the AWS IoT service to the edge environment where devices live. So it brings a local gateway for routing MQTT messages between devices at the edge. It acts as a bridge to the cloud. It introduces local Lambda, so it allows you to author code on the internet in the cloud and deploy that down to Greengrass. And it incorporates all the best aspects of AWS security. It's important to understand that Greengrass is not hardware, it's software. You bring your own. So one of our customers, Rio Tinto, have installed the Greengrass on a hardware module in their haul trucks. You can install it on Maker-style devices like Intel Edisons and Raspberry Pis. You can install it on internet gateways. So I'll talk a little bit about an example of Technicolor, and they're deploying internet gateways with Greengrass enabled. And you can prototype solutions on EC2 instances, which makes it very easy to get started. So the AWS IoT service looks like that in the middle there. And we introduced the Greengrass service, and this is running at the edge. And you can see that it looks very similar to the AWS IoT service, but it's running in the local environment where the devices live. It includes the ability to the ability to route messages at the edge, securely connect them in. It's got a local shadow service. It allows you to run Lambda functions at the edge. Greengrass itself will run on virtually any connected device with an x86 or ARM processor. And it acts as a bridge to the cloud. And this brings several benefits. So now you can write code in the cloud which can quickly respond to local events. So if you have an alerting alarming system or you have a command and control requirement, you can deploy Lambda code and it's running in your local network. One of the design principles of Greengrass is that it'll run disconnected. So if you lose internet connectivity, your Greengrass environment will keep running. It simplifies device programming. Previous to this, when you're deploying code to a local environment, you needed to use embedded programming techniques and models and have monolithic firmware updates. This moves to a model which is a lot more familiar to cloud developers. It reduces the cost. So now you can do a lot of pre-processing using Lambda of data at the edge and aggregate and filter the data and summarize it before you send it up to the cloud. And you can aggregate that while you don't have an internet connection, and when an internet connection becomes available, you can send it up. And it's all wrapped up in AWS grade security. I'll talk a little bit about some of the features of Greengrass. Just quickly, Greengrass, you've got two bits of software which work hand in hand with each other. You've got the Greengrass core, which is the Greengrass software, the Greengrass runtime, and you've got the IoT device SDK. Now, the Greengrass core is the bit of software which is responsible for doing the local brokering of messages, the local gateway. It is responsible for running local Lambdas. It is responsible for interacting with the AWS Cloud, and it has a local shadow service. The IoT device SDK, which already existed with the AWS IoT service, allowed you to configure devices to talk up to the cloud. You can now use the SDK and configure it to connect to the Greengrass core locally. And these devices that work locally with the Greengrass core form part of what is known as a Greengrass group. So, to get some key concepts across about how Greengrass works, you create in the console a Greengrass group, which is logically your edge environment. And a Greengrass group consists of three things. It consists of the Greengrass cores, which are the runtimes running Greengrass, Greengrass devices, which are the devices, and the Lambdas. So a Greengrass group is made of cores, devices, and Lambdas. And they communicate at the edge with each other. When you go to set up your first Greengrass group, you firstly create your first Greengrass core. You then add devices to the group. You then deploy that group down to, you download the Greengrass runtime and the security credentials. You configure it on your local device, and the Greengrass group is then live on the Greengrass core. You can then configure a Lambda in the cloud and deploy that down to the Greengrass group. And Greengrass works with IoT to maintain long-lived connections. You have a situation where a Greengrass group you have to be connected to the cloud to do the initial setup, and you need to be connected to the cloud to do updates to the Greengrass core. So one of the design principles, as I mentioned earlier, was that Greengrass couldn't run disconnected, but it needs to connect for setup and ongoing maintenance. You also can do a lot of processing locally with the Greengrass, with a local Lambda in the Greengrass core, and processing of the data that's been collected from your devices. You can summarize and filter and prepare this data, and then you can transfer that to the cloud when you have an internet connection. A little bit about Lambda. So who's used Lambda? So Lambda has been around for a few years now. It's event-driven compute functions. So in the cloud, previously you could create a Lambda function. You could create it in a language that you were used to developing in, such as Python or JavaScript or Java. You could create this Lambda function, and the function was triggered by an event. So a classic archetypal use case for Lambda would be a file arrives in an S3 bucket, and that's an event that triggers a Lambda function. That Lambda function's job is to process that file and create an output file in another bucket. So in very much, you only pay for the cycle times to execute that function when the event occurs, and you get charged in increments of 100 milliseconds. So developers loved Lambda because it allowed them to very quickly and cost-effectively build serverless solutions. So we're extending this functionality down to the Greengrass core. So you can have Lambda functions which are triggered by MQTT messages at the edge. We support Python 2.7 in Greengrass at the moment, with more to come. And it really simplifies the cloud development model at the edge. I might talk about a bit of an example with local Lambda. So imagine a medical facility. If those of you who have worked with medical equipment know that they can generate terabytes of data every day. Imagine that these devices are communicating with the local Greengrass core. You've got a local Lambda function there which has the job of responding to medical alerts, for example, if it sees a certain condition on these devices. It's very important that this local Lambda function continues to operate if you're disconnected from the network. But these devices are generating lots and lots of data. And one of the things we hear from our customers, and also specifically with research customers, is that preparing data for analysis can sometimes form up to 80% of a researcher or a data scientist's job. So imagine that the data is being collected in Greengrass, and you can start to clean and filter and prepare that data for analysis. Then you can upload the cleansed data to the cloud, and you can run some deep analytics on it. You can look for insights, and then you can go back and say, how can I update my Lambda function now to run improved? You can improve the operation of your edge environment. Also, you can use techniques around machine learning to train models in the cloud and deploy them locally as well in local Lambdas. Local Lambdas can use 3 SDKs at this point in time. They can make use of the bulk standard AWS SDK. So local Lambdas can consume cloud services if they're connected to the internet. So you could have a local Lambda who is copying files to an S3 bucket. They can use the IoT SDK. So a local Lambda can also appear as an IoT device if you need to do that. And there's a Greengrass SDK, which allows you as a local Lambda to trigger other local Lambdas and to get and set the state of things in the local network, and to publish arbitrary MQTT messages out on the local network. Now, I talked a little bit about shadows earlier, and this is about how you manage to set and get the state of things when you're a developer and things get disconnected, drop on and off the network over time. So with Greengrass, you have a local shadow service. So you can write local Lambda code that is interacting with devices at the edge that may or may not be connected. You can also optionally send shadow information to the cloud. So after this session, if you go to the booth and you go to the AWS booth in the middle of the hall, a colleague of mine has set up an elevator demo which shows this. There's an elevator which is it's a pretend elevator that's showing what floor 2 elevators are on. There's a Greengrass core and a local Lambda that's updating the elevator about where it's at. And he's got a workflow that allows you from the cloud to interact with the shadow service in the cloud to put a lift into maintenance. So it'll interact with the shadow service in the cloud. That shadow for the elevator is replicated between the Greengrass and the IoT. That will update the state of the elevator in the Greengrass core to put it into maintenance, and you can see that the workflow flows down from the cloud to the Greengrass group. If in the demo he loses internet connectivity, the lifts continue to operate. Sorry, one too far. And security is very important for our customers. All communications within a Greengrass group are encrypted, and all devices that connect into a Greengrass group have to be mutually authenticated. Devices use credentials that they get generated in the IoT service, and then they have to get connectivity information to connect to the Greengrass core. Each Greengrass core has its own root CA, and that is changed over a period of time that you get to set. We also introduced a new concept with Greengrass called subscriptions. So in the cloud, you have, if you had devices connecting to the IoT service, they could publish messages on an arbitrary topic, and other devices and services which had permissions to connect to the IoT endpoint would be able to see those messages. With Greengrass, you have to explicitly set the source and the destination of all the Greengrass messages. And none of this takes away, of course, if you're writing code and you're writing local Lambdas, you need to follow good security practices. And in the partner community, we're working with device makers, OEMs, software partners, operating systems makers to incorporate Greengrass into the next generation of their devices. Sorry, I was one slide behind. And at launch, we launched with many partners. Canonical, who provide Ubuntu operating system, they're going to include Greengrass in their snap channels. Intel are going to include Greengrass support in their next enterprise development kit for their next generation of gateways. Qualcomm have included it support for Greengrass in one of their popular Dragon board devices. And the Raspberry Pi Foundation has announced that they're going to bring to the Raspberry Pi the power of the AWS Cloud, which I think is a pretty exciting announcement. And locally, Rio Tinto, as I mentioned earlier, installed Greengrass on a hardware module in their haul trucks. Now, these trucks have a lot of telemetry devices, sensors, etc., and they collect a lot of information. The Greengrass module was collecting a whole bunch of data around the performance of these trucks in these remote mining sites. And when the trucks got back to base, a lot of this data has been collected and analysed to improve the safety and the efficiency of these devices. And they saw results after just a few weeks and are looking at how they can get more value out of the Greengrass service as well. And Technicolor, and I wasn't aware of this, Technicolor is one of the world's leading producer of internet gateways. And they've produced this gateway, which isn't on market yet, I don't believe, but if you copy down that URL, you can type in, go to the search and search for Alexa. You can see what these gateways are going to do. It's got the Alexa voice service installed in it, and it's also got Greengrass. And you'll see an interaction in the video where the owner of this device goes, Alexa, configure my Wi-Fi extender, because there's a companion Wi-Fi extender device. And Alexa goes, do you mean Wi-Fi extender 1234? And the owner says yes, and it configures the device. So there you have an interesting workflow where you're using voice control to trigger a local Lambda to do local network connectivity. But they see this going even further. They see this as a full-service internet gateway. Imagine that your network provider could install a local Lambda on this device to monitor the state of your internet connection. Has anyone ever had internet connectivity problem in this country? So the network provider gets the ability to see in real time the state of all their connections, or the lack of state, indicating a problem. They can automatically start to address problems without waiting for customers to call in. So it saves the provider money, and it's a better experience for customers. But you can even take this an extra step further. Imagine you're a home automation company, and currently you have to deploy a separate home automation sort of controller or gateway to a local environment. Imagine they could just deploy that as a Lambda code to a single Greengrass device. You have this ability to almost make the internet gateway like an app store for home consumers. And we introduced the Snowball Edge device. So this is a ruggedized storage device that people use to move terabytes of data to the cloud. So it's got an e-ink display which shows the address and changes when you're sending it back, which people love. It's also got compute in it. It's got an M4 4x large or equivalent of that in there for compute, and it's got Greengrass. So GE are using this in their wind farms. So wind farms are typically like wind. It's quite remote. and they collect a lot of data locally, and they can process that data and even act on that data using Greengrass locally. And the Hatfield Marine Science Centre, as part of Oregon State Uni, use these devices on their marine vessels. Previously, they had to use a lot of consumer-grade hard drives that they had to, it was very difficult to manage and, remember where all the data was. Now they take one of these devices onto their boats, and they're collecting the data. As I mentioned, researchers spend a lot of time processing the data. So with this device, they can process the data as it's being collected, and when the device is full, they just ship it back to us, and all their data appears in an S3 bucket, which is pretty cool. So we have this old world of edge computing. We've got monolithic software. I'm installing a firmware update. Am I going to brick my device? Is this the end as I know it? You've got techniques for programming these devices, which are embedded languages and practices, and you've got a very diverse range of protocols and standards. And in this new world, you've got software which you can create using cloud development model, and you can then deploy down to the edge using your existing practices. Pricing for this service. So any messages which are transmitted at the edge between the Greengrass core and devices is free. Any internet transfer from the Greengrass to AWS and back is just standard charges. First 3 devices, and by devices I mean Greengrass cores, first 3 are free for 1 year, and then up to 10,000, it's 16 cents to 22 cents per month, and it's cheaper if you commit for a year. And if you've got over 10,000 devices, give me a call. So after this, I'd advise you to go to these links. So go check out that video on the Internet Gateway. To me, it really illustrated the power of this new Greengrass paradigm. Read the blog, which goes through initial setup of Greengrass, so you can get familiar with the concepts and set it up in an EC2 instance or on a Raspberry Pi or something like that. And then go through the tutorial. You'll get your first Lambda function running, and you'll get the sense of, okay, this is how I can use this platform. I think it's early days for Internet of Things and edge computing, and I think Greengrass is an exciting step that Amazon's taking and a big bet on how we see the future, and I hope you do too. So thank you very much.